All right, this is part 2 of the lecture about profit maximizing input application rates. This is the slide that we ended with in part 1 of this technical lecture. And we said that if a producer is facing this particular response function, response curve, we ask, well, how much would that producer want to, how much nitrogen fertilizer would that producer want to put on? And we said, well, if the person puts on 100 pounds, then and then puts on just a little more, like 105, there's a pretty big increase in yield, and therefore it's a good idea to go from 100 to 105. So at 100, in a sense, this response function is too steep. The marginal product of nitrogen is high, and so you want to add more. On the other hand, if the person was here at point C, at this amount of nitrogen, I think it's 190, if you increased by 5, you'd get very little response in yield, and therefore it's a bad idea to increase by 5. If, on the other hand, you decrease by 5, you really wouldn't get that much of a loss in yield. So it might make sense to decrease nitrogen because nitrogen costs money, and you wouldn't lose much yield if you're already at 190 to go down to 185. So in other words, at this lower nitrogen rate of 100, the curve is too steep to stop putting on more in. And at this nitrogen rate of about 190, the curve is flat enough that it doesn't hurt you very much to lower nitrogen. Actually, it helps you in the sense that you don't have to pay for the nitrogen and you don't lose much yield. To think about this question of what's the optimal N, let's learn about something first called an isoprofit line. Here's what an isoprofit line is. Okay? An isoprofit line is a line at which the profits are equal at every point. So, if here we have a graph with a corn yield, Y, on the vertical axis, and nitrogen fertilizer, N, on the horizontal axis, okay, then I want to think about the points, the NY points in this diagram that give us exactly $250 per acre in profits. Now the most obvious point is this point. If we put on 0 nitrogen, we know that the field will yield 50 pounds in corn. Okay? So if you have 50 pounds in corn, then your revenues are 5 times 50, P times 50. And your costs for nitrogen are 0 because you're not putting on any nitrogen. So your costs are 50 times 0.50 times 0, which is 0. And so your profits then are 5 times 50, which is $250. So here is one point. The point is 0.50. And at that point, profits are $250 per acre. Okay. Now, let's find another point that gives us $250 per acre. Well, let's go to 1051. So we're blowing up the picture much bigger again. Well, if we go to 1051, so now we're going to use 10 pounds of nitrogen instead of 0. And so if we use 10 pounds of nitrogen instead of 0, then that's going to cost us $5 because 10 pounds of nitrogen at 50 cents a pound is $5. So what we'd have to do is we're going to have to increase revenues by $5. And so to increase revenues by $5, we have to increase bushels by 1 because the price is $5 a bushel for corn. So 0.50 and 1051 are both going to get us $250 an acre. Look at it. P times 51 minus W times 10, okay, equals 5 times 51 minus 0.50 times 10, okay, and that is going to equal 250. You can work that out, okay. So this point is going to raise costs to move from 0.50 to 0.51, raises cost by $5 and raises revenue by $5, and therefore the profits are the same on both those points. In the same way, every time we add 10 pounds of nitrogen and 1 bushel of corn, it costs us $5 more, but we get $5 in extra revenue. So profits stay at $250 an acre. So if we go from 0.50 to 1051, we've added 10 pounds of nitrogen and got 1 more bushel of corn. Add 10 pounds of nitrogen and get 1 more bushel of corn, that puts us at 2052. At 2052, profits again are $250 per acre. 10 more pounds of nitrogen, 53 bushels of corn. As long as we keep going to this 10-to-1 ratio, over 10 and up 1, we're going to continue to make profits of $250 an acre. Everywhere on this line. In fact, what we call this is an ISO profit line. ISO in Greek means the same. And everything on this line right here, everything on this line gets us $250 in profit per acre. Okay? Now, that was just one line. That was the one that got us profits of $250 an acre. If we think about the line that goes through this point, the profit here at this point is, the profits here at this point are 100 bushels, because that's how many, what yield is 100, times $5 a bushel, and then you're using no nitrogen, so costs are 0, and you're making $500 an acre at this point. Well, every time you increase N by 10 pounds and yield by 1 pound, you're still going to make that $500 because you've increased revenue by $5, and you've increased costs by $5, and you've increased revenues by $5. So 500 pounds per acre is how much is made everywhere on this line. Similarly on this line, with a slope of W over P equal 1 over 10. All the profits are $750 an acre. Okay. Magic rule. If we want to call N happy face the economically optimal nitrogen rate, okay, the economically optimal profit maximizing pi maxing N rate. If we call that N happy face, then N happy face is where the slope of the response function equals W over P, which is the ratio of the prices. Okay. Magic rule, N happy face is where the response function equals W over P. All right. W here is 5, is 0.50. P is 5.00. Okay. And where the slope of the response function equals 1/10, that's going to be where N happy face is. Where the slope of the response function equals 1/10, that will be where N happy face is.